Hi, my name is Andrew and I'll be explaining the boundary conditions used to solve the Navier-Stokes equations of motion. A boundary layer is a layer of fluid which interacts with the surface via viscous forces. The no-slip condition states that at the surface, the velocity of the fluid must be zero, and due to viscous forces, this boundary layer develops. When enclosed on both sides, the development of this boundary layer is called developing flow, and once the boundary layer fully engulfs the flow is fully developed. The no-slip condition is a useful boundary condition to use because at the wall the velocity of the flow is zero, and that's pretty widely applicable. Another boundary condition we use is the symmetry or no-flux condition, and this states that there's no flux about an axis, and therefore the change in speed at that point is zero. And this is another very useful boundary condition as it can be applied very often to Poisson flow. Another useful boundary condition is the constant flux condition. And this is used for multi-species interfaces. When used for liquid-liquid interfaces, it basically states that the shear stress from one liquid is equal and opposite to the shear stress from the other. And that can be seen in this equation here. Because of this, at the interface, the velocities are actually equal. A special case of this condition is when liquid and gas interface. Due to the high viscosity of liquid compared to gas, it can be reasonably approximated that change in the velocity profile is equal to zero. We use these boundary conditions to solve for integration constants from our Navier-Stokes equations. Typically this is done by applying the simplified Navier-Stokes equation to the boundary condition, and then the integration constant c can be solved for. Remember these boundary conditions and think about their limitations. Thanks!